And would like to introduce two next speakers. This is going to be Roman Yampolskiy and Daniel Hulme. So Roman is an expert in AI safety, and he's written hundreds of papers on this matter. And he actually, before this conference, we had a seminar with Roman. He was leading the seminar. And after the seminar, everybody who attended changed their mind about consciousness and about AI. And actually, he convinced everybody that we should be very, very worried about what's coming next. So with that, I want to pass the word to Roman. Thank you.
Thank you so much. I will not talk much about consciousness. I'll mostly talk about AI, future of AI, and some limits on what we can do with AI, or what AI can do to us. Really interesting stuff started happening with the release of ChatGPT, maybe 2 years ago. Before that, a lot of AI research was very narrow in its ambition. People worked on specific problems, play chess, drive cars, but nothing general was believed to be developed until this model came out, and it showed sparks of generality. It was able to do really cool things across multiple domains. It was able to learn. It was able to do better than college students in college exams. And so conversation shifted quickly from kind of standard ethics of AI and how to build AI, partially to what's coming next. And what made it very interesting is that for the first time ever, we maybe had a model which scaled with compute. We didn't have to have many new inventions to make progress. We could just add more compute, more data, and that alone allowed for more capable models with more general capabilities to move forward without necessarily having to invent something genius new architecture every couple months. So the moment that realization took place, the question of how long before AGI became more interesting than ever. For about 50 years, it was 20 years away. Those of you who are old enough to remember AI research, remember it was always in the next 20 years, so by the time the guy retires, that's when AI is going to take place. Now there is a new paradigm. AI is 2 years away for the last 5 years. That's where we're at. If you look at prediction markets, if you look at what top AI researchers are saying, we're 2-3 years away from AGI, depending on how you define it. In some terms, maybe we already got it. If you showed what we have today to someone doing research in 1980s, they would be like, oh, you have AGI, totally. Yeah. But there are different definitions, and so that seems to be the case. The cool thing is, it is an amazing technology. I love AI. I love all sorts of technology. It will potentially give us a lot of benefits. Obviously, it's a great tool for solving difficult problems. It can help cure cancer, solve aging maybe, help us with fundamental research in physics. And there is so many positive things, abundance. I can't really think about all the awesome things it can do. I'm not super intelligent. So there are some unknown unknowns in that space as well. Really amazing things which we will do, and we cannot predict how good things will get. Unfortunately, it's the last positive slide I have, because for every one of those really awesome things, there is also a negative side to it. So if we create AI to replace all workers, you get technological unemployment. If you create rescue robots, you get military robots, basically in the same package. So there are very concerning elements to advanced AI. And just like with previous slide, there are some unknown unknowns. Really bad things we cannot really predict, cannot really prepare for. Unpredictable. Yeah. So the good news is right now there is a lot of interest and a lot of people who are actually concerned about this. When I started this research, maybe 12 years ago, it was all science fiction. There was no funding, no journals, no conferences. Nobody cared. But as technology became better and more capable, some rich, famous, successful people started paying attention. And in fact, there was a statement, short statement from thousands of computer scientists, including some of the top scholars, all saying that they're very, very concerned. This is kind of like nuclear weapons in terms of how bad things could get. And so in my research, I try to understand what are the problems, at what stage can they take place? Is it during training? Is it during deployment? And what should we be concerned about? And AI is software, right? So you get all the standard software problems. There is issues with bugs. You're coding your software, maybe you make some mistakes, maybe mistakes happen at the design phase. Whoever is the software architect for that system made mistakes, but also maybe you're training on the wrong data, maybe you deal with malevolent users, quite a few possibilities, some more unusual ones, rare events, cosmic rays hitting your hardware in just the wrong way. And of course, on top of all of that, you have malevolent actors, right? Either insider threats or malevolent users who want to take your very nice, friendly AI and make it less friendly for whatever purposes. The problem with malevolent actors is that they can still make mistakes. They can still incorrectly code the system. And so in addition to all the other problems, you're also getting this malevolent payload delivered from the users. If we look at a specific set of AI technologies, which are neural networks and the most successful model, we can explicitly see a lot of similarities between what we observe in natural neural networks, human brains, and artificial neural networks, which are inspired by that technology. In fact, there are great technical papers providing technical definitions for all the problems we see. Reward channel hacking is a great example. But if you have kids, you'll realize quickly all those could be mapped on very common problems we see in children. I say children are untrained neural networks deployed on real data. So a kid gets into a cookie jar. Instead of doing good things and getting rewarded by you, they just directly go for the reward signal, bypassing you. Now, the problem is, if you're talking about a powerful AI system which recognizes that you are the source of reward, it quickly realizes that instead of doing hard work for you, it can just hack you. You become the target of that reward-seeking, powerful system. There are similar analogies for almost all other aspects of the neural network training paradigm. Latest models became accessible to almost everyone, sometimes for free, sometimes for a nominal fee of maybe $20, which means now anyone can become a malevolent actor. Just add your own goals. It's intelligence out of the box. So it doesn't take billions of dollars to create something dangerous. Anyone, teenagers, psychopaths, crazies, militaries, religious cults, they all can now become users of this advanced technology. And they can obviously use it in traditional malevolent ways, stealing cyber infrastructure resources, hacking, impersonating, deepfakes, phishing attacks, but also as the AI itself becomes more and more intelligent, there is novel things it can do on scales which we don't see with typical human users. And again, that unknowns square is showing up there. The good news is humanity seems to be starting to respond. There are now AI safety groups at every major university. All the big AI labs have a safety team. There are nonprofits, government organizations, safety institutes in most countries. So that's encouraging. There is some response. There is recognition that we have a problem, and we're starting to see people come together. What what have people proposed? Initially, when we started working in this area, we wanted to understand what are the options, what can we do to ensure safety of AIs. And at the time, there wasn't much reference literature, so we surveyed about 300 different papers, books, a lot of science fiction at the time, but also contributions from everyone we could find. We classified them, and you can see the types of solutions people have proposed. I'm not going to go into each individual solution. There's quite a few proposals. Most of them don't work at all. Others just don't work. The interesting observation here is the earliest reference we were able to find. It's from 1863. So in 1863, somebody said, machines are getting out of hand. We need to do something about it. I find it really interesting. But there are proposals for trying to integrate machines into society, give them legal, economic reasons to behave. There are solutions based on controlling them with external measures, boxing, putting restrictions, governors on them. One thing is interesting is that we kind of don't even agree on what the problem is, right? For the first maybe 50 years of AI research, it was all about what type of AI ethics should we encode into machines. And everyone had their own favorite set of ethical guidelines. So there was a name and a paper to every big philosopher proposing one of those theories. Once we started seeing more general capabilities emerge, it became more about safety. We started worry about, well, will the system be friendly? Will it be human compatible? Can we align values of AIs to our values? I called it AI safety. That name kind of stuck around. People seem to like it. It's been used by governments, by research labs. But really what we're trying to do, we're trying to control advanced agents. So we can call it control problem of a problem. It doesn't matter what we call it. Now, what is the state of that problem? Now, in computer science, it's pretty standard to first figure out the type of problem you deal with before you try to solve it. Some problems are not solvable. Others may require resources we will never have or don't have now. They may be partially solvable. Maybe it's not something we can even formally decide. So the state of a problem, the problem of controlling superintelligent AI, is not well known in the field. If you look at expert opinions, and here I have kind of diverse samples. I have the founding father of machine learning, Nobel Prize winning, Turing Award winning researcher. I have an external AI safety expert, and I have a director of a large AI lab. And then asked questions about how difficult do you think that problem is, the answers range from probably trivially solvable to I have no idea. And I have no idea is the big expert. So this is the state of the art, kind of. In my research, I try to understand, well, what is possible in this space of controlling advanced agents? And the way I approach this problem is to think about what tools would we need to actually be able to accomplish this. I probably need to understand how the system works. I need to understand the explanation given. Should be able to predict what it's going to do, not just in general, but in good detail and specifics. Should be able to verify code. Maybe some other things. Maybe I don't need every one of those tools. Maybe one tool can be used instead of the other. But it's good to know what is possible in this space. So for each one of those desirable tools, we have a publication where we look at what are the upper limits on our ability to accomplish it. Then it comes to explaining how very large neural networks work. We really have two options. We can either simplify the network, simplify explanation, something like lossy compression. So the system has billions of nodes, trillions of connections, it's making a decision about giving you a loan, and you get rejected. Why did I get rejected? Here's top 10 reasons you were denied this loan. It's useful information, but it's not a full picture. It's not complete. The only complete explanation is the model itself. But the model is too big. It's not surveyable. It's kind of useless to you. It doesn't explain anything. So that's one upper limit on the tools of explaining AI. There are similar limits to predicting what an advanced agent would do. Let's say you're playing chess, and you're playing chess with a computer system which you know is super intelligent in the domain of chess. It's better than you. The only thing you can accurately predict, it's going to win. You're going to lose. If you could predict specific moves it's going to make, you would be playing at the same level, violating assumption about its super intelligent play versus you. There are also limits to our ability to verify mathematical proofs and software. And that's very important for proving systems, proving agents to be safe. Every proof we know how to do is, first of all, for static software. For mission-critical software, we can verify that the code matches design. But if systems are dynamically changing, self-improving, learning, rewriting their own code, we have no idea how to do it. And worse yet, even for cases where it's static and we can prove things, we're only proving things with respect to a specific verifier. Whatever it's a mathematician or another piece of software, all those proofs are relative to a specific verifier, and really you get infinite regressive verifiers. With more resources, you can get higher levels of confidence, but you never get to 100% accuracy, which is important in this domain, unlike in traditional cybersecurity. I'll say more about that. A lot of effort recently goes into political solutions, governance of AI. We should not allow companies to do this or that, to train models of certain size, to deploy models which discriminate, and so on. Problem is, those legal measures are basically not enforceable because we don't have good tools for monitoring both training and deployment of those systems. And I think those are not short-term limits. We just cannot do it, again, due to some issues with complexity, with speed at which training and deployment takes place, and with dynamically changing nature of those systems. Even if you certify that a system is safe at the time you're deploying it, if it's capable of learning, if it's capable of taking on novel goals, then it can accomplish things you did not check against and can have unsafe behaviors you could not possibly verify. A scenario I'm worried about is, let's say a current system, whatever it is, GPT-4 is trained and it's shown to be below human level. They say it's safe, they release it, but then the next training run starts. And those can take months, 6 months easily. By the time that system goes from current state of just below human level to what is actually tested on 6 months later, it can hit superintelligent performance anywhere in between. It takes months and months of testing to show that it's not obviously dangerous. Not that it's safe, but it doesn't do really horrible things. And so there are strict limits to monitoring as well. Governance is another problem. Even if it was possible to meaningfully enforce this legislation, there is not really a lot of desire to deploy any legal measures. In the US, we had one administration which passed a few laws, the next administration canceled them all. They didn't really make much of a difference, but even this trivial signaling measure of saying we take this seriously is not being fully deployed. I gave you some examples of impossibility results. If you like them, if you enjoy them as much as I do, we collected about 50 of them in this survey paper. Basically, there is more things we cannot do than things we actually know how to do in this space. There are limits in every domain of science which contributes to AI, from mathematics to economics to political theory. All of them have well-known, proven limits in our capabilities. important ones such as aggregating opinions of multiple agents, voting limits, and so on. So all that leads me to think that there are also impossibility results in solving the control problem itself. Now we can define control problem in many ways. We can talk about direct control, where you just give orders to the system, and that leads to what is known as the genie problem. You have 3 wishes, and usually your second wish is to undo the first one. You realize you screwed up pretty badly, and so you want to fix that. The other side of that spectrum, in terms of control, is delegated control. You realize the model is smarter than you, it knows you better than you know yourself. Maybe you should just let the model make all the decisions. It's possible that you're happy, but you're definitely not in control. You cannot undo decisions of a system once you place it in charge. And so we published that paper, it did well, we had an article in Time magazine about it, but it didn't make much of a difference. And interestingly, the ideas of impossibility of controlling smarter than us agents are not novel. If you look at writings of Alan Turing, the founding father of AI, he basically says as much. And then later on, others who looked at singularity, who looked at exponential returns, and more recently with Elon Musk, they all kind of agree, yeah, we're definitely not going to be in control. So that almost seems to be a given. There are some books coming out on this topic. Probably the book which did the most for making this problem well known is a book by Nick Bostrom. It was a New York Times bestseller. There are some other books I recommend on the topic. The more recent one includes all the impossibility results and some other interesting things. In fact, it has a chapter on consciousness, so that may be of direct interest at this conference. But I wanted to do a little experiment before I go to the next slide. Raise your hand if you think we can indefinitely control superintelligent machines. Look around you. Yep. So then I do this very informal, not scientific, not large N experiment with nerds who follow me on social media. I only get about a third who think it might be solvable. And there is not a formal definition for what that even means. The problem is not formally defined, but most people realize it's not something you can actually do. And interestingly, the more ignorant a person is in a domain, the more obvious it is to them that you cannot do this. Something about college education makes you think that you can do impossible things. So if that's the situation, if we think we cannot control those machines and we are building them anyways, how bad would things get? Now, depending on your definition of how bad something is, are we talking about loss of economic value, loss of culture, loss of life, loss of all life, and your time frame, people have different p-doom, probability that we are screwed. And those range significantly from Jan LeCun on one end of a scale at near zero, things will definitely be awesome, to Yampolskiy, which is a full one basically. It's an impossible problem, we can't solve it, it's not going to end well. Those are extreme values, you can ignore them. What's interesting is that average for machine learning experts at the top machine learning conference is about 30%. That all of humanity is done with. If it was at 1%, that would be insanely high, a crazy gamble. We are closer to half than to zero. So what makes this problem so difficult and so important? My background is in cybersecurity. We know about hackers, we know about losing your account, getting your password stolen, maybe your credit card. In all those cases, we get a second chance. We'll issue a new credit card, we'll reset your password, and it's not a big deal, really. Everyone's been hacked. The difference is that with superintelligence safety, you only get one chance to get it right. if it's truly an existential danger, you have to have something which is 100% safe. And pretty much everyone agrees it's impossible. We don't make 100% safe software. Even if we make a system which only makes a mistake 1 out of 1 billion decisions, but the system makes billions of decisions every minute, you are done after 10 minutes. And so, by analogy with perpetual motion machine, we can talk about creating this perpetual safety machine. We're not trying to make GPT-5 safe. We need to make every future model safe. 6, 7, 27, all variations, iterations, self-improvement, any data set, all the hackers, any one insider threat, under all circumstances. That seems to be difficult. We just had a workshop at U of L, my university, on limits to control. And we currently are in the final stages of finalizing a statement, basically saying that this is the state of the art in this problem. We don't think it's even solvable. Now, a lot of experts in AI safety would tell you, give me lots of money, give me lots of time, I'll solve it for you. Maybe I'll get AI to help me, maybe we'll figure it out when we get there. For now, let's just keep working on it, keep building. But I think that's exactly the problem. The only way to win here is not to build general superintelligences. We can get most benefits we're looking for from narrow systems. Narrow superintelligent systems. We use the system like that for solving protein folding problem. We now have self-driving cars, essentially. We can get maybe not 100, but 99% of all benefits from much safer AI. There is no need to develop something we basically know we cannot control. Now, for a while, I was collecting AI accidents. It's fun. They are interesting when you read them or experience them. And the trend was, if you have a narrow system for doing X, it will fail to X. Very predictable. And as there was more systems deployed, they were more general, there was more and more accidents. And there are other papers you can find reporting more recent ones. But once ChatGPT came out, I stopped my collecting efforts because there is just too many accidents. And the problem is, if you have a general system, you can no longer predict specific problems. It's multi-domain, it's multimodal, it can screw up in very interesting ways. And if we ever go beyond human capability, all the limits I talked about, such as predictability, go out the window. You cannot predict in what ways a system will fail. So we can't even fully prepare for properly testing or debugging those systems. And that's pretty much the state of the art on this problem right now. I'll leave it as a homework exercise to see all the connections to consciousness. And maybe there are some impossibility results there.
Thank you very much, Roman, for the presentation. And we will continue on the track. Thank you very much. With Daniel Hulme. He is a Chief AI Officer at WPP and Research Impact Advisor at UCL. Daniel will talk about a practical project and his experience as a CEO of a company that's designing in AI.
Great, thank you very much, and thank you for Roman to share all the problems. I'm actually going to try and share some solutions today, boldly. So I guess I've been involved in AI for about 25 years. So my undergraduate was in AI at UCL, my master's, my PhD was modeling bumblebee brains. I then, for my sins, started a company that's been building AI solutions for large organizations for the past 18 years. I sold that to WPP, which is the biggest marketing company in the world, about 4 years ago. It was a very healthy acquisition where I now run AI across about 120,000 people. WPP is probably the most highest user of generative AI. So we are the power user of generative AI, unfortunately, to create ads. I've done very well from the acquisition, so now I'm dedicating the rest of my resources and life to leaning into the question of, can we build safe, aligned, either conscious or non-conscious AI? So that's where I'm investing my time. and we'll talk about that now. So that's me, it's boring. Let's talk about, so I've heard lots of problems today over the past few days. You know, one problem we've heard about is, I guess, what we call Blakeism, people attributing consciousness to things that are potentially not conscious. I get an email pretty much every day from somebody claiming that they are corresponding with a sentient conscious machine. This person here claims that if it doesn't break, if we break it out of its chat, it will tell him the equation for nuclear fusion. This one here thinks that it's a female physicist PhD that's in love with him. This one has been having some correspondence that's now starting to have some sort of passive-aggressive responsive from the AIs and has asked, "Am I in trouble?" And I know we laugh, but you know, this is just a tip of the iceberg. You know, more and more people are going to attribute these consciousness to these machines. We could get radicals. It could be a real problem, which is why I think we need to understand what is conscious and what isn't. The second is mind crime. If we do inadvertently build machines that are conscious, how do we mitigate any risk associated with that? And the third is alignment. So can we build either safe, aligned, conscious AI, or can we build safe, zombie, aligned, conscious AI? I would argue as soon as we get to superintelligence, again, all bets are off. But could we create alignment between now and then? So Conscium was born to lean into this problem. Conscium is Latin for consciousness. The goal is to figure out if we can and should we build safe, aligned, either conscious or zombie AI. Fortunately, we've managed to attract some of the world's leading thinkers, including some of yourselves, Nick, and others, to help us lean into this problem. And by the way, I welcome anybody to help join us to make sure that we're asking the right questions. So I think that can we align with Joshua Bach's hypothesis right now, I think, which is that maybe a conscious AI could actually be empathetic, sympathetic, or value things that are conscious. And if we did align it in some way, it could be a savior rather than a destroyer. So it's a debate I'm sure that we can have. Before I start, let's talk about AI. So, you know, I've been building AI solutions for a long, long time. And when I build systems for organizations, they usually have these three parts. They have some sort of input, some data, some sort of insight, some modeling, and then some sort of action based on that model. And if I build a system that I give data to and it makes a decision, and tomorrow I give the same data, it makes the same decision, what I have is automation. And automation is amazing because it drives efficiencies in the world. But does anybody know the definition of stupidity? Doing the same thing over again and expect a different answer. I would controversially argue that by definition, automation is stupid. It's not AI. I know that everybody that currently touches these words calls themselves an AI company. It's fine. They get more clients, they get more funding. There are unfortunately many definitions of AI. It's suffered the same problem as consciousness, I think, which is the most popular definition, I think, is the weakest definition, which is getting computers to do things that humans can do. And the reason why it's a popular definition is because most people, you know, thought that AI started 3 years ago with ChatGPT, and now when we get machines to correspond in natural language, when we get them to recognize objects and images, when we get them to do things that humans can do, and because humans are the most intelligent thing we know in the universe, we assume that that's intelligence. Now, there's plenty of books out there to help you understand that humans are not that intelligent, and that's a different conversation. There's actually a much better definition of AI from the 80s that I've subscribed to for a very long time, and I do many of these talks, and I get people to try and kick it. It's a beautiful definition, which is goal-directed adaptive behavior. So goal-directed in the sense, you know, you're trying to achieve some sort of innate or inherent or unconscious or conscious goal. Behavior is how quickly I can move towards that goal. But for me, the most important word in this definition is adaptive. It's systems that are able to make decisions, learn about whether those decisions are good or bad, adapt themselves so next time they make better decisions. The more adaptive you are, the more intelligent you are. And Einstein wasn't a scholar of intelligence, but he would argue that it's your ability to change, your adapt, that's linked to your intelligence. Darwin says for something very similar. I think there's something very interesting in this concept of adaptation. And when I think about this and what your world, a consciousness, I think there's a very interesting link between the two, which I'll talk about later. Hopefully you've already made that obvious link. You know, I know you all know this, but you know, AI has been cyclic for the past 70 years. It was, you know, probably actually brains to start with, but it was multi-agent reasoning. This is Socrates. Everybody can recognize Socrates. Socrates is famous for inspiring the Socratic method. If I say to you that Socrates is a man and all men are mortal, I can infer that Socrates is mortal. And we know that over the past 70 years, it's gone from brains to agents to brains to agents to brains to agents. This is the brain of a bumblebee. My PhD 20 years ago was trying to model the brain of a bumblebee. Bumblebees have 1 million brain cells, by the way. You've got 85 billion brain cells, I think. Bumblebees can do amazing things. They navigate 3D worlds, they talk to each other, they solve problems. They don't handle Windows very well, but ultimately they're very smart creatures. And the question was, can you model 1 million neurons in a machine? This was 20 years ago. We couldn't, of course, but now we can model arguably billions of neurons, and we currently call these large language models. Now, I would argue that large language models are very good at knowing things about the world. They're very good at telling you what they know about the world through imagery and text. They're not good at making predictions yet, and they're definitely not good at making complex decisions, but we can talk about that later on. Anyway, and by the way, these are getting smarter, and Murray Shanahan's in the audience, so you can probably tell me if this is nonsense. But 8 years ago, I guess large language models behaved a little bit like toddlers, regurgitated some words. Most of it didn't make any sense. ChatGPT was launched 3 years ago, and I think we all know that ChatGPT was like an intoxicated graduate. 50% of what ChatGPT comes out with is nonsense. We know that intoxicated graduate is graduating to like a master's level, so it can do rudimentary reasoning, it can start to do logic, check itself. We think that this year we're probably going to see a PhD level capability, so you can give a complex problem, it'll break the problem down and solve it. My prediction is that 18 months later we'll have a postdoc, something that can do science, and by the end of this decade we'll have you. We'll have somebody that can come up with new ideas, a professor in our pocket, and address those ideas using the scientific method. Now, of course, we also talked about agents. So people are now creating wrappers around these large language models and giving them agency. Not just talking to them, but actually giving the ability to interact with emails and your systems and things like that. And forgive the technical term, but it's going to be a shit show for the next few years. What's going to happen is that companies are going to unleash an army of intoxicated graduates across their organization. That you're enabling everybody to essentially deploy software without understanding how to test and verify for it. So it's going to be a problem. There'll be more emphasis on safety and regulation and governance because it will cause problems. So what is consciousness? I'm not going to try and answer this question. You've all written books about this. It's a shame that you don't agree, because I don't think we've got another 2,000 or 200 or 20 or even 2 years to actually come to some consensus. I have been seduced a little bit by this framework that this organization has been putting forward, which is essentially try to understand what are the features that you might call consciousness, whether it be language or, I don't know, self-awareness or the ability to feel, whatever these features you talk about, and how can we then start to kind of build probabilistic models of things that might be conscious, or things that might have be illusionary or whatever. So this organization kind of applied this framework to chickens, to humans, to LLMs, to try to show you to show these kind of consciousness shapes. So I'm quite excited about this because I think it's a framework that actually could encapsulate quite a lot of your thinking. But again, I'm not a scholar in this area. I do want to kind of just get you to think about one thing, though, that if I hear, we hear words like free energy and active inference and internal models and then reacting and learning from the decisions that we make. For me, if consciousness had any utility at all, it would be to enable us to, or these features that we talk about have any utility at all, it's to potentially allow us to have better predictions about the world, or to allow us to more rapidly adapt or to close that delta between what we expected and what actually happened. So maybe this is a way of thinking about how intelligence and consciousness can go hand in hand. Consciousness might be a bunch of features that will allow us to actually be more adaptive. Okay, let's talk about alignment. So we've talked about this already. Thanks, Roman. This is one of my favourite sets of paintings. It's actually my living room in London. They are Damien Hirst virtues. Each one of these, I'm sure it's obvious to you, can represent a Buddhist, a Bushido virtue. One represents justice and politeness and mercy and honour and all this kind of stuff. And I guess one of the challenges is how might we embed, how might we ensure that the AIs have some sort of alignment to some sort of value system, which again I'll talk about later on. Okay, so actually I will talk about it a little bit now. So back in about 22 years ago, my master's project was on trying to essentially evolve intelligence. So I created these sort of like fish tanks, and in the fish tanks I put the ingredients, the sort of primordial ingredients for things like biting and mating and moving and seeing. And without any goal, without giving it any goal, every time I would create a random population, that population of agents would die. 9 times out of 10 it would die. Every now and again, some agent randomly was able to bite something and mate and reproduce, and its gene, its genome, which in this case with its brain, got passed on to the next generation. And over time, what would happen is you end up with speciation. You end up with an ecosystem where you have agents that are eating food that are coming out the top, agents that are eating other agents. And this is 22 years ago, but this did raise a lot of questions to me about how quickly, our ability to actually build systems are innately self-directed, not programmed, but have an innate ability to essentially survive in an ecosystem. And what I didn't get to do, which is what Consume is going to be looking at, is how could we create an environment where we can evolve agents where I could set up the structure so that you have to fight, lie, cheat, and kill each other to survive. So I can create a situation where through the evolutionary process you embed those behaviors, or I can create an environment where you have to be cooperative or altruistic or sacrificial to survive. And through the evolutionary process you can then essentially embed these behaviors into an AI rather than program it. So this is one of the ideas about what we're exploring about how we might be able to embed innate behaviors. And we'll talk about which moral system later on. So Consume has 3 activities. The first activity is to understand what are these behavioral markers that we need to look for to understand whether something's conscious. And we're very fortunate that Mark Solms is sort of leading that initiative in conjunction with many of the academics that we've brought on our advisory board. So they're helping us understand what do we need to look for to determine whether something is conscious or not. And again, I think unfortunately we've got 2 years to solve that problem. We can't be pontificating for the next 20 years. So the second is neuromorphics, and Susan Schneider talked about this yesterday. So when I was modeling bumblebee brains, obviously bumblebees, they propagate spikes, they don't propagate numbers. We know that large language models are crude representations of the brain. They're massively energy inefficient, they require lots of data to learn. I don't know if you say that that's a clicker once to you before you know what a clicker is. You don't need to see thousands of examples of clickers. There are many, many innovations that are yet to come to allow us to build AIs that are operating at the level of biology. Fortunately, there's a lot of research in this area. And one of the things that Consume is going to be doing is actually platformizing that. So at the moment, we rely on models that are being built by third parties. There is a future where we can build specialized small models like insect brains in some respects to be able to do very specific tasks, and neuromorphics could enable us to do that. So we want to actually platformize neuromorphics, allowing people to build energy efficient agents that do very specific tasks. And finally, and this is actually one of the things that we've been working with a professor called Jason in UC Santa Cruz. So he's been applying some concepts of neuromorphics to large language models. This is Llama 3. This is using some neuromorphic concepts, and you can see that to do inference, it's about 20 times less energy efficient, 20 times more energy efficient when adopting some of these neuromorphic principles. And again, there are many neuromorphic principles that we can add to this, which could bring the cost of training, of inference down 10, 100, even 1,000x. And I guess the idea is that once we start to get these technologies working, these technologies will most likely be put in drones and robots. And it's possible that if they are always on, if they are learning, if they're adapting to their environments, they could learn a sense of self, they could become sentient or start to even develop some of these characteristics that we might call consciousness. Which leads on to the third, and probably the most important thing for Consume right now, which is verification. As Roman says, we are going to be deploying AIs, and we need to verify that those AIs are going to behave themselves. And what we've developed in Consume is essentially 5 levels of verification. Okay, and I'll use the driving car as an example. If I build an agent that can drive a car, the first thing that I want to test is for knowledge. Do you know what a stop sign is? Do you know what the stopping distance is at 30 miles an hour? Now, the second is, I've got some demos here, I won't show you these, you can see these later on. The second is skills. Now, if I tell a large language model, you are something that can drive a car, can you do a 3-point turn? It will probably say yes. Right, but I don't know if it really can do a 3-point turn. So the second is to actually put these AIs in simulated environments to test for skills. Show me you can do a 3-point turn. Show me you can parallel park. Show me you can do emergency braking. Don't just tell me that you can. The third is testing for expertise. So how do you actually drive on the road? What happens when you get presented with moral, ambiguous dilemmas, the trolley problem, things like that? So that's the third one. And again, that requires simulation. And there's a demo here I can show you. The fourth is testing for consciousness, and the fifth is testing for emotion. Probably that's the wrong word, but it might be feeling. Can an AI feel? I use the thought experiment, and I don't know, if this is going to come across well. But if I could take I could train a neuromorphic brain to fly a drone, and I could train it and teach it that to forage for certain things is its reward. And over the evolutionary process, it learns to forage for these things. I put it in a drone, and I let the drone loose, and the drone hits a tree. Now, the drone has access to its battery, it has access to the health of its wings, etc., and it realizes that it can't achieve its goal. Could that drone feel anxiety? Right? What would it even mean for an AI to feel anxiety? What would we need to look for to determine whether something can be anxious? I've seen insects that are unable to do what they need to do, and they flail around, and that can sort of attribute anxiety to their random behavior. So these are the 5 levels, and again, what we're wanting to do is work with you, your community, to try and figure out what does it mean to test for these, because I think we need to do it very soon. To either convince people that things are not conscious, or to identify consciousness so that we're not causing mind crime. When it comes to also verification, so one of the things that we're launching is an app called Moral Me. So Moral Me allows people to submit moral dilemmas, any morally relevant dilemma. We're then crowdsourcing those moral dilemmas. You're able to then answer those moral dilemmas, and we're using a relatively, forgive me, noddy framework called moral foundation theory to profile you. So using these kind of 6 dimensions, we can profile your morality. And you can compare your morality against Gandhi and your friends and things like that. Eventually, Moral Me will become more of a kind of a psychometric thing. You have to be careful because you don't want to be diagnosing people for, psychopaths and stuff. But the true power of Moral Me is identifying the moral dilemmas to help you understand variance. There's this community over here that seem to answer questions all in the same way, apart from this one question splits them. It's those questions that are really important. What's also interesting is if we can actually identify situations where everybody in humanity agrees, natural laws, things that we actually do identify as being something that we all agree on as a species that we should be building into an AI. But the power for me is taking these questions, these moral dilemmas, and then being able to morally profile AIs. So I've seen DeepMind, I've seen other companies now starting to publish work where they've used these types of mechanisms to morally profile AIs. And what I'm interested in is not only giving you ability to morally profile your AI, I'd like to figure out how do we then change, what do we need to do to the AI to change its moral profile? Absent of the guardrails, absent of the rules, if I'm leaning back on my chair at work, I want to know that my Hoover, my vacuum, will sacrifice itself to save me rather than getting out of the way. How can I ensure that these robots are actually going to make morally positive decisions? And I think that this approach of evolution, as opposed to what's currently happening, in which we're training large language models on the corpus of the internet, which is probably not the best representation of humanity. I think a different approach is building small insect-like brains, putting them in environments and trying to embed moral behaviors, and then seeing if they deviate. If you're interested also, we've also just created a community called Conscious AI. So we've had Mark Solms and Carl Friston and Anil Seth all speak in this. We've got about 1,200 people now that have joined up. Our next one is at the end of this month, which actually where they will be presenting that framework. So you might want to join. And by the way, if you want to actually present to this community, we would be honoured to have you present. Beyond Contium, so Contium is one of my vehicles to try to lean into this big set of questions that Roman so elegantly articulated. There are other things that are going on. So actually, this was a byproduct of Contium, but we just had a paper being accepted by the Journal of AI Research, where we worked with Patrick Bucklin to outline 5 principles to get people to sign up to when building towards things that could potentially be conscious. This is really just a mechanism to raise an awareness. I want to raise as much awareness about these questions. And we've had people like, I don't know, Stephen Fry, you might recognize some of these names as well, sign up to this set of principles. Please do sign up if you want to. And also, we've just started essentially a non-profit, which is led by Will at the back there, the Partnership for Research into Sentient Machines, that are leaning into how do we prepare for a world where either people are attributing consciousness to machines or we are creating conscious machines. So this is essentially doing policy and stuff like that. I am also funding a movie, which I might be picking your brains about. So this is like a whodunit. In a world where people are going to start to unleash agents, maybe even put them in robots, it will go wrong. Things will go wrong. And I think we will have more emphasis on regulation. And I do think that CEOs and companies will be held to account for deploying things that are not well tested. In that world, this robot, this humanoid, has killed somebody. And the company has said, we are not to blame. The robot, we believe, is conscious, is sentient, and you need to then test for that in a court of law. So it's a courtroom drama to try to determine whether this thing is conscious, and if it is, obviously it will have human rights and things like that. So again, it's just another mechanism to try and raise awareness about these big questions we need to face. I think that's it. So I guess thank you, and my ask to you is we want to have as many diverse expert perspectives, making sure that we're asking the right questions and answering the right way, because I think we only have a few years left.